Mars Colonization, analyzing NASA's $10 billion investment in human exploration by 2030. Introduction. NASA's ambitious plan to colonize Mars represents a monumental step in human exploration with an investment of approximately $10 billion directed towards facilitating human missions to the Red Planet by the 2030s. This initiative is fueled by the need for scientific discovery and technological advancements that can potentially unravel the mysteries of life beyond Earth and enhance our understanding of our own planet's history. As we delve into the various aspects of this mission, it becomes clear that NASA's Mars colonization effort is not merely about reaching another planet but is a comprehensive approach that encompasses scientific inquiry, technological innovation, and human endurance. Scientific goals of Mars exploration. At the core of NASA's Mars exploration program are four primary scientific objectives. 1. Assessing past habitability. Scientists seek to understand whether Mars ever had conditions suitable for life. This involves studying geological formations and chemical signatures that hint at the planet's ancient environment. 2. Understanding Mars climate and geology. By analyzing the current climate and geological features, researchers aim to uncover the processes that have shaped Mars and how these compare to Earth. 3. Searching for signs of life. One of the most compelling questions driving the exploration of Mars is whether life ever existed there. Missions such as the Perseverance rover are equipped to search for biosignatures, evidence of past life. 4. Preparing for human exploration. This goal focuses on the technological and logistical challenges of sending humans to Mars, ensuring their safety and success during long-duration missions. NASA's rigorous approach emphasizes that understanding Mars is not only about potential life on the planet itself but also about gaining insights that could inform humanity's future in the cosmos. Source 2. Technological development for Mars missions. The technological challenges of sending humans to Mars are immense. NASA is currently developing several critical systems to support life and work on the Martian surface. Oxygen production. The Mars Oxygen In-Situ Resource Utilization Experiment MOXIE is a pivotal project aimed at producing oxygen from the Martian atmosphere, which is predominantly carbon dioxide. This technology will be crucial for both breathing and fuel production. Food sustainability. Given the long-duration missions to Mars, astronauts will not have the luxury of resupply missions. Therefore, NASA is researching self-sustaining food systems, including plant growth techniques that have been tested on the International Space Station. Source 1. Water recycling. Advanced life support systems are being developed to recycle water and other consumables, ensuring that astronauts can survive on Mars without resupply from Earth. Power sources. Reliable power systems are essential for sustained operations on Mars. NASA is exploring nuclear fission power as a robust alternative to solar energy, which may be unreliable during frequent dust storms. Habitat design. NASA envisions habitats that can provide astronauts with essential amenities similar to those found on Earth while also being capable of withstanding the harsh Martian environment. Source 1. CHAPEA missions, a step towards human exploration. To prepare for the realities of living on Mars, NASA launched the CHAPEA Crew Health and Performance Exploration Analog mission beginning on June 25, 2023. This year-long simulation at NASA's Johnson Space Center involves a 4-person crew tasked with performing various Mars-like activities including habitat maintenance, resource management, and coping with environmental stressors such as isolation and equipment failures. Source 3. The CHAPEA mission serves multiple purposes. Data collection. The mission aims to gather critical data on crew health and performance, which will inform future mission planning and support systems for astronauts on Mars. Simulated activities. Crew members participate in simulated spacewalks, robotic operations, and crop growth, replicating the challenges they would face on the Martian surface. Environmental stressors. By introducing factors such as resource limitations and isolation, NASA can study their impacts on crew dynamics and mental health. Vital aspects of long-term space missions. Mars environment and challenges. Mars presents a daunting array of challenges for human exploration. The planet's extreme conditions include temperature variability. Temperatures on Mars can range dramatically from -284 degrees Fahrenheit to 86 degrees Fahrenheit, creating difficulties for both habitat construction and astronaut safety. Atmospheric composition. Mars' atmosphere is composed of about 96% carbon dioxide, necessitating advanced life support systems for oxygen generation. Dust storms. Frequent and prolonged dust storms can last for months, which could hinder solar energy collection and require robust backup power systems. Source 1. Robotic precursor missions. NASA's history with Mars dates back over 60 years, during which numerous robotic missions have laid the groundwork for human exploration. These missions include Mars 2020 mission with Perseverance rover, launched in 2020. Perseverance is currently collecting samples and conducting experiments to find signs of past life. Source 2. Other robotic missions. Previous missions such as the Curiosity rover, In-Situ, and MAVEN have provided invaluable data regarding Mars' geology, climate, and potential habitability. Each robotic mission has contributed significantly to our understanding of Mars, informing preparations for future human exploration. Timeline of key events. 2020 – Launch of the Mars 2020 mission with Perseverance rover. 2023 – Initiation of the CHAPEA mission to simulate Mars living conditions. 2030s – Targeted timeframe for sending humans to Mars as part of NASA's broader exploration strategy. Conclusion. NASA's $10 billion investment in Mars colonization reflects a multifaceted approach to exploring and potentially inhabiting another planet. Through scientific inquiry, technological innovation, and extensive preparatory missions like CHAPEA, NASA is laying the groundwork for one of humanity's most ambitious undertakings. The insights gained from Mars exploration will not only advance our understanding of the cosmos but also promote technological developments that can benefit life on Earth. As we approach the 2030s, the groundwork being laid today will pave the way for future generations of explorers to step onto the Martian surface, marking a monumental achievement in human history. Counterintuitive information regarding NASA's $10 billion investment in Mars colonization includes the following points. 1. Focus on technological innovation versus immediate human benefit. While the investment is primarily aimed at human exploration of Mars, the technological advancements developed through this initiative may not directly benefit Earth in the short term. The technologies required for Mars colonization, such as oxygen production systems, advanced life support, and reliable power sources, are designed for extreme conditions on Mars which may not find immediate applications on Earth, countering the common expectation that space exploration should yield quick benefits for humanity. 2. Increased reliance on nuclear power rather than solar. Although solar power is typically seen as a clean and sustainable energy source, NASA's plans for Mars missions indicate a preference for nuclear fission power due to the planet's frequent and prolonged dust storms. This reliance on nuclear energy contradicts the public perception that solar energy is the most viable option for off-world exploration given the harsh Martian environment. 3. CHAPEA missions and potential psychological impacts. The CHAPEA mission's year-long simulation is expected to gather data on crew health and performance, focusing on isolation and resource limitations. However, the counterintuitive aspect is that while this simulation aims to prepare astronauts for the psychological stresses of long-duration space missions, the environmental stressors they face may not fully replicate the actual psychological effects experienced during real Mars missions, such as the intensity of the unknown and the challenges of truly being light years away from Earth. For robotic precursor missions over human exploration, NASA's long history of robotic missions to Mars, which have provided crucial data without any human presence, may suggest that human exploration is not as necessary for scientific discovery as once thought. This presents a counterintuitive notion that we may achieve significant scientific breakthroughs without sending humans to Mars, which challenges the narrative that human presence is essential for exploration. 5. Mars as a hazardous environment for human life. public perceptions often romanticize the idea of colonizing Mars, viewing it as the next frontier. However, the extreme conditions such as temperatures that can plunge to -284 degrees Fahrenheit and a thin atmosphere composed mostly of carbon dioxide highlight the dangers associated with colonization. This reality contrasts with the idealistic view of Mars as a habitable location, underscoring the considerable risks involved in human exploration. 6. The timeframe of exploration. While the investment aims for human exploration by the 2030s, the timeline has been met with skepticism by experts who cite technological safety and logistical challenges that could delay manned missions. This contrasts with public expectations of rapid advancements and immediate timelines, revealing a disconnect between investment intentions and practical realities. 7. Potential for life versus human settlement. The primary scientific goal of Mars exploration is to search for signs of past life which may not correlate with the potential for human settlement. This raises a counterintuitive question about the motivation behind colonization efforts. Are we investing in exploring Mars to seek life or to establish a human presence? The emphasis on extraterrestrial life discovery may overshadow the practical challenges of sustaining human life on Mars. These counterintuitive insights challenge conventional wisdom surrounding space exploration and Mars colonization, illustrating the complexities and nuances of NASA's ambitious plans. NASA's $10 billion investment in Mars colonization by the 2030s represents a pivotal moment in human exploration and technological advancement. While the report outlines various aspects of this ambitious initiative, several critical points may be overlooked, yet they hold significant implications for the future of both space exploration and life on Earth. 1. Self-sufficiency in space. One of the most crucial yet understated aspects of NASA's Mars mission is the emphasis on creating self-sufficient habitats for astronauts. Given that resupply missions will not be feasible during long-duration missions, technologies for oxygen production, water recycling, and food sustainability must be developed and tested. The report highlights that systems like the Mars Oxygen In-Situ Resource Utilization Experiment MOXIE are vital for producing oxygen from the Martian atmosphere, which could enable fuel burning and breathable air. Significance. The ability to produce essential resources on Mars is not only fundamental for survival but also represents a broader shift towards sustainability in space exploration. This self-sufficiency model could inform future missions to other celestial bodies and even drive innovations in resource management on Earth, particularly in water-scarce regions. 2. Human factors in long-duration missions. The CHAPEA crew health and performance exploration analog missions are a critical yet often under-discussed component of NASA's preparation for Mars exploration. These year-long simulations focus on crew health and performance under conditions that mimic the Martian environment. Participants face various stressors, including resource limitations and isolation, which are pivotal for understanding how to support astronaut well-being during extended missions. Significance. This research on human factors is essential, as psychological and physiological stressors can significantly impact mission success. The findings from CHAPEA could lead to better training and support systems for astronauts, with potential applications in high-stress professions on Earth such as healthcare and military operations. 3. Technological innovations beyond space exploration. While the report emphasizes the technological advancements required for Mars exploration, it is important to note that the technologies developed for this purpose could have transformative effects on life on Earth. For example, advancements in water recycling and sustainable food production systems could provide solutions to global challenges like water scarcity and food insecurity. Significance. The cross-pollination of technologies designed for space exploration with those needed on Earth underscores the dual benefit of space programs. By investing in these technologies, NASA not only prepares for Mars colonization but also contributes to solving pressing issues facing humanity today. 4. International collaboration in space exploration. NASA's Mars colonization efforts are not solely an American endeavor. They represent a collaborative global effort. The planned return of Martian samples to Earth involves partnerships with the European Space Agency (ESA) among others. This collaboration illustrates a broader trend in space exploration where international partnerships are increasingly essential. Significance: the collaborative nature of space exploration fosters peaceful relations between nations and encourages the sharing of knowledge and technology. This could pave the way for future joint missions to other celestial bodies, promoting a sense of global unity in the quest for knowledge beyond our planet. 5. Understanding Mars as a proxy for Earth. The scientific objectives of Mars exploration include understanding the planet's climate, geology, and potential for life. Insights gained from studying Mars not only enhance our understanding of the red planet but also provide a comparative framework for understanding Earth's past and future. And mathematics fields. The excitement surrounding space exploration can inspire the next generation of scientists and engineers. Significance: engaging the public in the narrative of exploration fosters a culture of curiosity and innovation. The educational outreach associated with space missions can have lasting effects on society, encouraging young people to pursue careers in STEM and contribute to future advancements. 7. Ethical considerations of colonization. While the report primarily focuses on the technological and scientific aspects of Mars colonization, the ethical implications of such endeavors are often overlooked. Issues surrounding planetary protection, the potential for contamination, and the moral responsibilities of colonization are critical topics that warrant discussion. Significance: addressing the ethical dimensions of Mars colonization is vital to ensure that exploration is conducted responsibly. Developing frameworks for planetary stewardship can guide future missions and promote sustainable practices that honor both the Martian environment and humanity's role in the cosmos. Conclusion: NASA's $10 billion investment in Mars colonization is a multifaceted initiative with far-reaching implications. The overlooked aspects of self-sufficiency, human factors research, technological innovation, international collaboration, scientific understanding, public engagement, and ethical considerations are all critical components that will shape the future of space exploration and our understanding of life on Earth. As we move closer to the reality of human missions to Mars, it is essential to recognize and address these factors to ensure the success and sustainability of our endeavors beyond our planet. For most valuable points in NASA's $10 billion investment for Mars colonization. 1. Scientific exploration and the search for life. NASA's Mars colonization initiative is fundamentally driven by its ambitious scientific objectives. The exploration program's four main goals: assessing past habitability, understanding Mars climate and geology, searching for signs of life, and preparing for human exploration, underscore its importance. By investigating whether Mars was once habitable and if it still harbors life, NASA aims to answer profound questions about our existence and the potential for life beyond Earth. The scientific insights gained from Mars could significantly enhance our understanding of Earth's own history, climate change, and the potential for life elsewhere in the cosmos. 2. Technological innovations for sustainable living. The technological advancements being developed for human missions to Mars are a cornerstone of NASA's strategy. These innovations include life support systems for oxygen production, water recycling, food sustainability, and reliable power sources such as fission power. The focus on creating self-sufficient habitats is crucial given the anticipated long-duration missions with no resupply options. This technological groundwork not only prepares for Mars colonization but also has the potential for applications on Earth, particularly in sustainability and resource management. 3. CHAPEA missions and human factors research. The CHAPEA crew health and performance exploration analog missions represent a significant step in preparing for human life on Mars. By simulating Mars-like conditions over a year, these missions gather essential data on crew health and performance under stressors such as isolation and resource limitations. This research is invaluable in understanding how to support astronauts during long-term missions, addressing psychological and physical challenges and ensuring the safety and well-being of future crews on Mars. The insights gained from CHAPEA will inform not only Mars missions but also future long-duration space travel. 4. Understanding Mars' extreme environment. Mars presents a range of harsh environmental challenges, including extreme temperatures, a thin atmosphere composed mainly of carbon dioxide, and frequent dust storms. These factors complicate everything from habitat design to energy generation, making it essential to develop robust systems that can withstand these conditions. Understanding these challenges is critical for mission planning and technology development. NASA's approach to addressing these extreme conditions will be pivotal in ensuring the safety and success of human exploration on the Red Planet. Conclusion: NASA's $10 billion investment in Mars colonization is not merely about reaching another planet. It encompasses a comprehensive approach to scientific discovery, technological innovation, human factors research, and environmental understanding. Each of these points plays a vital role in the overarching goal of establishing a human presence on Mars and enhancing our knowledge of the universe. As humanity stands on the brink of interplanetary exploration, NASA's efforts could lead to groundbreaking discoveries that reshape our understanding of life, sustainability, and our place in the cosmos. 1. The Apollo Program 1961–1972. NASA's Apollo program was a landmark achievement in human space exploration, culminating in the first manned moon landing in 1969. The program's objective was to land humans on the moon and bring them safely back to Earth, which it successfully accomplished 6 times between 1969 and 1972. The investment in technology and scientific research during Apollo laid the groundwork for future space missions, including those aimed at Mars. Involving multiple countries and agencies mirrors the potential for international cooperation in Mars colonization efforts. 3. Mars Pathfinder 1996–1997. The Mars Pathfinder mission was pivotal in demonstrating the feasibility of landing and operating robotic vehicles on Mars. It included the Sojourner rover, which was the first successful rover to explore the Martian surface. The mission provided valuable data on Mars geology and atmosphere, significantly contributing to our understanding of the planet. Its success laid the foundation for future rover missions such as Spirit and Opportunity, and ultimately for human exploration, showcasing the importance of robotic precursors in preparing for manned missions. NASA's $10 billion investment in Mars colonization signifies a monumental step in human exploration, setting ambitious goals for the 2030s. This initiative is not merely an exploration venture but a comprehensive program aimed at unraveling the mysteries of Mars, enhancing our technological capabilities, and potentially paving the way for human life beyond Earth. Future outlook and predictions. 1. Human missions to Mars by the 2030s. The most immediate prediction is that NASA will successfully launch human missions to Mars by the early to mid-2030s. With ongoing advancements in technology and results from analog missions like CHAPEA, the groundwork will be laid for a crewed mission that can sustain human life in Mars' harsh environment. By the end of this decade, we might witness the first human footprints on Martian soil. 2. Technological innovations. NASA's focus on developing life support systems will lead to breakthroughs in sustainability. Technologies for in-situ resource utilization (ISRU), such as oxygen production from Martian CO2, will drastically reduce the dependency on Earth for supplies. By 2030, we can expect these systems to be operational, creating a self-sufficient habitat for astronauts. 3. Robotic precursor missions. Continuous robotic missions will persist, serving as scouts to gather crucial data about Mars' surface and atmosphere. These missions will further refine our understanding of Martian geology and climate, providing insights that will guide human exploration. By 2030, we can expect a comprehensive database of Mars conditions, enhancing mission planning. 4. International collaboration. As NASA progresses towards Mars, international partnerships will play a crucial role in the endeavor. The collaborative model established through programs like the Artemis missions is likely to extend to Mars exploration, fostering shared resources, knowledge, and technology. By 2030, we may see a coalition of spacefaring nations working together to achieve common goals on Mars. 5. Scientific discoveries. The scientific goals of Mars exploration will yield groundbreaking discoveries about the planet's potential for past life. As missions like Perseverance collect and analyze samples, we can anticipate significant findings that could reshape our understanding of life in the universe. By 2035, we could have compelling evidence of microbial life existing on Mars, leading to a paradigm shift in astrobiology. 6. Sustainable living solutions. Research conducted during the CHAPEA missions will inform strategies for long-term human habitation on Mars. The development of sustainable food systems, water recycling technologies, and energy generation through fission power will be crucial. By 2035, we may witness the implementation of these systems, enabling astronauts to live and work on Mars for extended periods. 7. Private sector involvement. The burgeoning space industry will increasingly contribute to Mars colonization efforts. Private companies focused on space travel and technology will likely provide innovative solutions and support for NASA's missions. By 2030, we could see commercial partnerships facilitating transport, logistics, and even colonization initiatives. 8. Public interest and engagement. As the timeline toward Mars human missions progresses, public interest and support will likely grow. Educational outreach and transparency in mission goals will enhance public engagement, fostering a global community invested in the success of Mars colonization. By 2030, we can expect a well-informed public that actively participates in discussions and initiatives related to Mars exploration. And responsibility towards other worlds will become more prominent. By 2040, we may witness an evolution in human perspective on life beyond Earth and our responsibilities as stewards of other planets. Conclusion. NASA's investment in Mars colonization is not just a scientific endeavor, it represents a bold vision for humanity's future. The predictions for the next 2 decades offer a glimpse into a world where humans are not only explorers but potential settlers of Mars. By addressing the challenges of life on another planet, we will not only expand our horizons but also inspire generations to dream beyond the stars. The journey to Mars will redefine our understanding of life, technology, and our place in the cosmos.